ring topology basically, and what are the advantages of ring topology over the bus and tree topology. And in fact, the ring provides the highest throughput among all the um, other topologies, like in especially in case of when see, there can be two things, right? One is that every node has data. When we talk about a ring topology, and every node has a data, so everyone like, because once one station finishes its transmission, the turn is passed to the next station, right? So everyone has data in that sense. Am I audible to you? Am
Yes,
I?
sir.
Okay. So, so if all the stations have data, it will provide you we say when the traffic is high, right? Everyone is having sufficient data to send, because otherwise what will happen if all the stations are not having data, they will simply pass their turn. Suppose station A transmits, okay, and then once it completes its transmission, it passes the turn to station B. Then B has no data. Then it passes to C. C also has no data. Then it passes to D, and D also has no data. Then it comes back to A, right? So if uh, the traffic is not moderate, then in that case, the ring performance decreases, right? But when you talk about the busy conditions, the rings gives the best performance. Okay, so we were discussing about the limitations, like the potential ring problems in our previous class. So I'll be just continuing that. Uh, I told you about what are the possible things, like a cable vulnerability, and so if any cable cut is there, it is difficult. Perambulation, repeater failure. Locating a repeater failure is also a very tedious task, because where exactly the fault has happened, you have to trace in all the possible rooms where exactly the repeater, which repeater is particularly failed. And when we talk about when we have to install new repeaters, the new repeaters are to be installed in such a way that the that doesn't change the mm, uh, geometry of the ring, right? That doesn't make the geometry of the ring as irregular, right? So it needs to be taken care when you are connecting a new station, that that it should be at an equal distance from the adjacent repeaters, right? And so that the geometry of the ring is maintained, right? So these are the some of the points. And there was another thing that I told, that there is a possibility that a factor which limits the number of repeaters on a ring, right? So that is nothing but that is called as a timing jitter, because as I told you that um, once the whether the repeater is in the listen state or in the transmit state, they introduces a 1 bit delay, right? Because all the bit stream which is on the ring needs to be scanned by the repeater in order to identify the destination address. And once they scan it and then regenerate it on the ring, that introduces a 1 bit time delay, right? So if we have if we increase the number of repeaters, you may say that because each repeater is associated with a station that acts as an attachment device with the station. So if we increase the number of stations or number of repeaters on a ring, then that may finally lead to more delay, because the repeater gets two types of clocks, right? And this timing jitter is nothing but deviation of the clock, right? Because you should know, the repeater should know when the incoming bit stream is starting, when the incoming bit stream is ending, right? So repeater uh, once it receives data, it recovers the clocking for two purposes, right? It has got two purposes. for which it receives the clocking first to know when to sample the incoming signal to recover the data, right? When it has to start sampling the incoming signal to recover the data, and the second is to transmit the clocking for transmitting the differential Manchester signal to the next repeater. Okay, so as you know that when we use a twisted pair or coaxial cable ring length, digital signaling is used basically. Okay, we which coding we use for digital signaling? Hmm? Which uh, which which ca- uh, which signaling technique we use? Which encoding technique? We use Y-phase coding, Y-phase encoding scheme. Generally, we use differential Manchester. तो differential Manchester में क्या होता था? Are they self-clocking codes? Do you remember differential Manchester? हाँ? Karthik Rai, do you remember differential Manchester?
No, sir, I don't remember it specifically.
Do you remember? Are they self-clocking or not?
What, sir?
These things are important. You should remember. Huh? If you remember, there used to be a like once there is a high, low, high, low. So once you go, there for us biphase encoding or Manchester encoding, there used to be a transition. Always there is a transition at the mid of the bit, right? So that acts as a self clocking. So that acts as a clock. So these codes are known as self clocking codes, right? We need not to provide any external clock. So from these data bits, the repeaters are supposed to extract the. So when this data circulates around the ring, each receiver must recover the binary data from the received signal, right? So, so to do that, the receiver needs to know the starting and ending times of each bit, right? Bit कहाँ शुरू हो रहा है, कहाँ खत्म हो रहा है, so that it can sample the received signal properly. So this requires that all the repeaters on the ring needs to be synchronized. Okay. Are you following? Why we require a synchronization? Because the receiver needs to, once the data is moving on the ring, the repeater needs to know that when it has to sample the data, whether from where the bit is starting, where it is ending. So for that, each repeater needs to be synchronized, and we use biphase encoding technique, which is known as a self-clocking codes, right? So basically this clock recovery deviates in a random fashion from the mid-bit transition of the received. Uh, so from the mid-bit transition, this clocking deviates. So once it deviates, what happens? You will, I told you na yesterday, delay distortion. Because of the velocity of propagation of a signal changes, varies with frequency in a guided medium, right? So that results in a intersymbol interference. Yesterday I told you na that one bit will the pulse will one pulse will spill over into the another pulse, right? So that will give the intersymbol interference. So this is nothing but this deviation of clock is known as the timing jitter, right? So so generally होता क्या है, once you are sampling at a wrong period of time, what will happen? Sometimes this pulse will get expanded, sometime it will get contract, right? So what will happen? Because of this, the bit latency of the bit length of the ring changes. Sometimes you will be the number of bits on the ring are increasing. So finally, because the bit length of the ring is constant, so some of the bits are to be dropped, right? Some of the bits needs to be dropped, or sometimes once this gets contracted, you need more bits to more random bits to be added, right? So this effect basically puts a limitation on the number of repeaters on a ring topology. So what is the solution for that? So, but this issue is still be there because of the noise and other reasons that results in the random variation of the this clock midwit transition, right? So there are many ways by which we can deal with it. So the solution for timing jitter lies in three things, right? We can have either elastic buffer. So what is the job of an elastic buffer? Elastic buffer, what it will do? So this buffer can also, when the number of bits on the ring is increasing, it will hold the extra bits, right? And so this in this way the ring bit length of the ring can be maintained and the bits will not be dropped. But so this can be done, okay. So we can include an elastic buffer in one of the repeaters. So this can be installed in a you can say the monitor station, because on a ring topology, when we say there can be a one station can be designated as a monitor station, because the monitor station has got some other responsibilities as well. The monitor station is responsible for deciding that who will for coordinating with other stations, right? If there is some error, no station is removing a frame, right? If the source station is not removing a frame from the LAN, I told you now that if a frame is transmitted by station A is responsible for removing it from the ring. But if suppose source station gets down, right? It transmits a frame and immediately it turns down. Then who will remove the frame, right? So there should be someone who will take care, who will take who can manage these operations. So in such scenarios, the monitor station will be responsible for removing a frame, and many such responsibilities are there, as we will talk on about token ring, where the maintenance of the token is to be done by a monitor station. So monitor station like a just like a class monitor, okay. So that monitor station it will be held responsible for many things, such things that if some right. So generally we install an elastic buffer at a uh, and monitor station can also help when we are implementing a centralized control scheme, right? I told you that the control can be implemented either in a centralized manner or in a distributed manner. So when I am saying about the centralized manner, the monitor station will be responsible for maintaining that. So this elastic buffer can be uh, uh, can be included at the monitor station, right? So this elastic buffer can expand and contract, right? So when the number of the bits on the ring increases, this buffer gets expanded, right? So generally in a IEEE 802.5, this buffer is of 6 bits, right? So that can from 3 bit to 6 bits, this can expand or contract from 3 to 6 bits, right? So this buffer can be put. Another solution can be each repeater can include a PLL. आप बताओ, आप तो पढ़ के आए हो, this is called as a phase lock loop. What is the use of PLL? Huh? Anyone? Anyone? Ehsan? Ehsan?
Sir, don't remember, sir.
Ayush Paul?
Sir, don't remember.
अभी तुम लोग कैंपस में बैठोगे ना इस सेमेस्टर में, तो वहां पे भी यही बोलोगे क्या? आई डोंट रिमेम्बर. अभी समर ट्रेनिंग के लिए यू मे हैव टू फेस सम इंटरव्यू, देन for the placement also you may have to face some interviews, right? So how will you say that you do not remember these things? Encoding techniques I do not remember. तो फिर आपको क्या रिमेम्बर है, बोलो? What do you remember? See, these things can be asked in an interview also, like when you are sitting for a campus interview, then these things can also be asked there. Sajal Nigam. Sajal Nigam. Pranish. 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 I take attendance multiple times. Don't think that if I have taken this attendance, I will choose the minimum one. If people are leaving, if that sir has taken attendance, I may take attendance again. It's not like that. And most probably it is going to be an offline examination, because very soon this third wave is going to end and you people have to face an online examination. Okay, so what? So either we can one repeater can include each repeater can be included a PLL, phase lock loop. Okay, so basically, what is the use of a phase lock loop? It basically it uses feedback. Okay, to minimize the deviation from one bit time to the next. It reduces the jitter, but still there will be an accumulation around the ring. So we can include a supplementary measure of this elastic buffer, right? That can hold a certain number of bits and expand and contracts as needed. So in a IEEE standard specification specifies a 6-bit buffer, right? So initially it can hold 3 bits, but as the bits come in, they are placed in the buffer for 3 bit times before being retransmitted. So this buffer can expand to 6 bits. So initially a 3 bits it will hold, then it will can expand up to 6 bits. So if the received signal at the monitor station is slightly faster than the master clock, the buffer will expand as required to hold 4th, 5th or 6th bits to avoid dropping of bits. But if the received signal is slow, the buffer will contract to 210 bits to avoid adding bits to the repeated bit stream. So this is how this is done. So basically another solution is to use both, because this also doesn't eliminate completely the effect of timing jitter. So the another possible solution is to use both PLL plus elastic buffer, right? So that basically helps, but still that is basically employed in an IBM ring. Okay, that in an IBM ring that basically holds maximum number of 260 repeaters. Okay, that can hold with 260 repeaters using a twisted pair, shielded twisted pair, right? And 72 repeaters with unshielded twisted pair, right? Because the actual limit, uh, because these measures increases the ring length, but to some extent, because actual limit depends on the characteristics of the transmission medium. Okay, which transmission media you are using, so which basically determine the amount of delay distortion and therefore the amount of accumulated jitter. So how can this we are this looks like that ring synchronization. So I have a monitor station here. Elastic buffer. This is a master clock. This is a master clock. Okay, and this is a monitor station. N number. PLL. So each repeater will include a PLL, right? And 1, 2, 3. So this is ring synchronization. I hope it is clear that what is a timing jitter, how the clock deviates, right? So what will happen? What happens basically that because the clock is recovered from the incoming signal, the timing error cannot be eliminated. So the digital pulse width will expand or contract depending on in a random fashion as the signal travels around the ring, right? So the timing jitter accumulates, and finally what happened, this cumulative effect of the jitter is to cause the bit length of the ring to vary. So unless the bit length of the ring remains constant, the extra bits are to be dropped, okay, not retransmitted. So as the latency of the ring decreases, right? So so this effect leads to puts a uh, bar on the maximum number of repeaters that can be put in a ring topology, right? So these are the some potential ring problems. I have already discussed the advantages of the ring, right? Now another architecture that is uh, sample the incoming signal to recover the data and to use the clocking for transmitting the signal to the next repeater. Okay. Because as you know that there is a clocking is at the mid of the this pulse, right? So if you are sampling at this position, the pulse width may vary, right? If you are sampling at a wrong position, where to start, where to end, so this will change the pulse width. Now star ring, you know, so two observations we made in a with the ring architecture, that there is a limitation on the number of repeaters, right? And there is a perambulation problem, that what it was, it was a pocket full of keys. So you have to search, if a repeater fails, you have to search each room, that where exactly the repeater is filled, right, to identify the fault. So these observation leads to the development of a refined ring architecture. This is also called as a ring wiring concentrator, right? And or we say it as a hybrid topology, right? That exploits the benefit of star ring architectures and overcomes the limitations of the ring architecture, right? So there were two limitations, that there was a limit on the number of repeaters because of timing jitter, accumulation of the timing jitter, and there was a perambulation problem, that is nothing but where exactly the fault is there, and because of that the entire communication in the network stops, right? So to overcome these two effects, basically this refined architecture is here, and this this overcomes the some of the problems of the ring and allows the construction of larger ring networks. So basically our idea is that we want to make use of ring architecture, but how can we cover for a larger geographical area? So when we are going for a larger network, how can we do that? Because there is a limitation on the number of repeaters, obviously in a ring architecture, because of the timing jitter issue. So just to overcome that, we are doing it in this. So this rearrangement of a ring into a star. Okay, so ring is rearranged into a star, and this is achieved through that by having the inter repeater links all threads through a single site. So you can see there is a wire center, right? There is a wire center. All the wires run through this wire center. So this is nothing but that the repeater, these repeaters are connected to the other repeaters in a, this is nothing but a ring only. So it acts like a, but this rearrangement, this ring is rearranged in the form of a star, right? So you can see here that all the wires from this repeater through this wire center, right? So all the threads of inter repeater links goes through a single site. So if suppose if we talk about that, how will it resolve the issues which lies in the ring topology, you can see that if suppose this portion is cut, right, or this repeater is not working, then also the communication can be possible, right? The data transfer is possible through the other ways, right? It will not disrupt the entire communication, right? And it is very easily to isolate a fault, because where exactly the fault is there, you can easily identify it, because the one portion of the this portion will not work, so you can easily identify a fault. Because how can you trace it? You can transmit a message in the ring and can see that where it goes, right? And you can track it how far it goes without any mishap, right? So faulty segment can be disconnected. So no pocket full of keys are required. So perambulation issue can be resolved, right? Perambulation issue can be resolved easily, right? And it can be repaired at a later time. So, and it also has an advantage that suppose, as I told you, that what was the issue with the ring topology, that when you have to add a new repeater, you need to be very careful because you need not to change the geometry. It should not change the geometry of the ring, right? But that issue is also resolved here, because when you have to add some new repeaters to this, you have to simply run two cables from the wiring center and splice into the ring, right? So you can easily run a new two wires from the wiring center and can splice it into the ring, right? So you can see that uh, the transmission path from one working repeater to the other working repeater is approximately constant, right? So this ring wiring concentrator greatly elevates the perambulation and installation problems, right? Mm. It also permits rapid recovery from a cable or repeater failure. Uh, so initially there was a uh, uh, suppose if a repeater fails, initially the communication will stop, but easily the fault can be identified and that section can be cut from the complete thing, and then the communication can resume. But only, can you say the issue with this ring wiring concentrator? What is the disadvantage? Anyone? Anyone? See, it requires a lot of cabling, right? Because the ring wiring concentration, if you it requires a lot of cabling, right? So that is the disadvantage of it, and moreover, it doesn't resolve the issue of timing jitter, right? This doesn't recover. Because throughput and jitter consideration still puts a limitation on the number of repeaters in a ring. So to attack these remaining problems, jitter and throughput, because देखो jitter आपका क्या कर रहा है, jitter आपको बोल रहा है कि you cannot have more number of repeaters, more number of station on a LAN, ring LAN, right? But what could be the possible solution? जैसे मैंने आपको कल दिखाया सिग्नल बैलेंसिंग का, what could be the possible solution? The possible solution is that we can have smaller rings connected uh, through some bridge, right? So we can have smaller rings. So smaller rings means if it is inter ring traffic, it will improve, or if it is intra ring traffic, no issue. If other ring fails also, right, that will continue. So what is the solution to deal with this jitter issue and lot of cable requirement? So jitter issue can be resolved only when we can have smaller rings connected with some bridge, right? And cable requirement is also very high in case of this ring star ring architecture. So how can this architecture be refined more, so that we can deal with these remaining two issues, right? So as I said that we can connect it with a bridge. So before going to discuss this problem further, let us discuss what is a bridge. right? We say it as a bridge or a layer 2 switch. We will deal this. These are known as an intermediate devices. These devices are used to interconnect different LANs, right? So they act as an intermediate device. So I told you that earlier also that in this 7 layers, right, or 5 layers of this TCP/IP model, this we below the physical layer there is a passive hub. Passive hub is nothing but a connector, right? It's simply connector, just wires. It will simply connect the wires. So it acts below the physical layer, and at the physical layer we have active hub. Why I have written a or a layer 2 switch? What is the meaning of a layer 2 switch? That it acts at the physical and data link layer, right? So the active hub or a repeater, right, acts at the physical layer, and the bridge or a layer 2 switch acts at physical and data link layer, right? Physical and data link layer means they have something related for the physical layer also, and performs filtering and other things from the data link layer, right? And when I say about the 3 layer or a router, that is works from 3 layers: physical, data link and network. So that is router or a layer 3 switch, right? So we will discuss these things in detail, but before that we deal with this bridge, right? What is the difference in a bridge and a layer 2 switch? They are also different. Can you say what is the difference? Anyone? Bridge or a layer 2 switch? Huh? What is the difference? Bridge or a layer 2 switch? Both are almost same, but there is some difference that you should say. What is that? From the name itself, it is clear. What is the difference? Layer 2 switch, when you are saying a switch is nothing but your it is implemented in hardware, right? And the bridge is implemented in software. If you see here that what are intermediate device, I discussed it earlier also that there are two AND systems, right? There are two AND systems. You should be very clear about these things. Two AND systems mean these are the two AND users, right? On this this end user may be using many applications here, right? File transfer protocol, Gmail, Facebook, and at this side this is also using a Facebook and Twitter. So they are using many applications at this side and this side, right? So in between these two end users, because they are a part of a network, they're connected to a network. So in a network there will be many other devices also. In between these two end users there will be many devices, and these devices are mainly we can term them as an intermediate devices, right? Or there will be other end users, or there can be a intermediate devices such as bridge, router, or 2-layer switch, 3-layer switch. In your hostel, if you remember, what is that? In a switch room, there is a switch room na in the hostel. What is there in the switch room? In the switch room there is a 2-layer switch, right? 2-layer switch or a 3-layer switch. So those switches are there. If you see them in your hostel room, right, where it is there, you will find there is a switch, LAN switch, right? So so those are the intermediate devices. So you know that the data transfer from the data link layer is responsible for node to node delivery from this end user to this intermediate system. Who will take care of this? Data link, right? And from this end user, this intermediate device to this intermediate device, once again, data link will take care. Then from this intermediate to this end system, also data link will take care, will be responsible for delivery between the node to this node, and will also perform error and flow control, right? But when I'm saying from this end user to this end user, who will be responsible? This network layer. Network layer, how does the network layer identify? Using an IP address. So using an IP address, this end user, these two end users will be identified by their IP address, and these intermediate devices will be identified by their MAC addresses and IP addresses, right? If it is a 3-layer, it will be, if it is a router, it will be identified by a IP address, right? So network layer is responsible for end user to end user delivery, right? And the transport layer is responsible for process to process delivery. This is also Facebook. This is also Facebook. So from, if you are chatting with your friend in Facebook with another friend, that he is also using Facebook. So Facebook to Facebook delivery will be taken care by the transport layer. Process to process delivery, and we say end to end, process to process delivery. So there it performs error and flow control on a process to process delivery, right? And this is the reliable thing. So process to process delivery. So how a process is identified on a system? I told you that the system is the end user is identified by an IP address, and this end user may be running many applications, right? So some of the applications are having a predefined port number. Just a file transfer protocol, it is having a some fixed port number, that on this port number only this file transfer protocol will run. So other applications, it is dynamically assigned port numbers. So that we will discuss when we will enter into that transport layer, that how the port numbers are assigned. Okay, what are the different ways of the port numbers? But for now, you should understand that this file, these different processes running on this end user will be identified by a port number, right? So once we add this port number to the IP, it becomes a socket address, right? It becomes a socket address. So a socket address is used at the transport layer to perform a process to process delivery, right? So how does, now we are concerned about the bus, this bridge operation. Before starting this bridge operation, I must tell you that this data link layer in a IEEE 802 reference model, which is suggested by a committee, right, for the local area network. We will discuss this again, that this data link layer is divided into two parts, LLC and MAC. MAC is basically medium access control, as I told you, to provide access over the shared medium, right? This MAC is used, and LLC is logical link control. Can you say what is LLC? You must be knowing LLC and MAC. Anyone? Anyone? Hmm? It's called as a logical link control. So this basically takes care of the data transfer between the two LLC users, means link link users. Basically, it is a data link, right? And this link layer is divided into two parts: this control part and this link logical link control, right? To establish a link and then perform the data transfer. So it provides different types of services. Okay, so that we will discuss the LLC and MAC. Okay, so before going to that, we go to bridge, right? So what is the function of a bridge, right? There is a Ethernet LAN this side. There is another Ethernet LAN on this side. So as you know that the stations are connected on a LAN through the network interface card. How do you connect to a LAN? You have a network interface card in your system, right? So that through that network interface card you are connected to a LAN, right? So there are many stations, the stations connected on LAN A and LAN B. So the bridge is basically used to extend the length of the network, right? Because there are potential issues in the Ethernet LAN. I told you that how the length of the ring, how the length of the network is. Why we cannot have a single LAN? Can you say why we cannot have a single LAN in the entire campus? Can you say why? बता सकते हो क्यों? एक ही पूरे कैंपस में एक ही LAN क्यों नहीं रख सकते हैं? There is a issue, reliability issue, because if you connect all the devices, suppose if I say about BIT, if all the devices are connected to only one particular network, okay, so if any issue occurs, if any breakdown occurs, or any fault occurs on the network, that will result in that will disable the communication for all the devices, right? So we cannot have a single LAN because of a reliability issue. The second issue is performance, right? As you know that when the more number of users are connecting on the same wire or on the same LAN, what is going to happen? The performance is going to decrease because the same bandwidth which you are sharing, suppose earlier it was 10 Mbps, which was shared only by one user. Now there are two users. Obviously the bandwidth will be shared. Similarly, three users and n number of users comes, then obviously the performance will decrease, right? So instead of having a single LAN, because single LAN will result in reliability issue, performance issue, then security issue, right? You do not know who is connected. So suppose if you do not want that any important data from account should be passed to the other sections of the other offices, right? Then that cannot be implemented when you have a single LAN, because LAN means what? It's a shared medium. So everybody is entitled to use that and for the data, right? Anyone can take the data. So then the geographical issue also comes. Suppose if there are two buildings, okay, one at the right side of the highway, one at the left side of the highway, right? So how will you connect them? Using a single link. So these things puts a bar on the having a single LAN. So what is the solution? Solution is to have smaller LANs, right? Smaller LANs interconnected with the bridges, right? और भी आपको जैसे मैंने बताया था कि if you have a larger LAN, a signal transmitted via this particular station, which will be transmitted in the form of voltage pulses, and what will happen due to attenuation, the signal strength will fall, right? So you need to install repeaters. Okay, otherwise what will happen? You will not be able to. I told you about the collision issue. So you do not know, the receiver will not be able to identify the transmitted data. So these things puts the limitation on a single LAN. So we need to connect smaller LANs through bridges. So इसके आगे का हम लोग नेक्स्ट क्लास में करेंगे, क्योंकि अब टाइम हो गया.